Okay, so I think we'll start without delay. My name is Jill Clyburn, and I am the moderator for the Solar 2020 poster session. This session is a living demonstration of the breadth and diversity and quality of work in solar today. We have 20 altogether poster presentations, and we're going to be urging you to take a listen, get to know what posters you're most interested in, and then take a trip over to the exhibit hall, and you'll see I think it's the very first booth where you can click and see the full poster for each of these folks. Communicating with our speakers is also going to be really important because, you know, maybe they're working in a field that you're interested in, or maybe you have a further question. Use the chat box in that exhibit hall in order to leave a note for these folks. We will have time for a few questions, but we're going to make the Q&A kind of short. Don't hesitate to ask if you do have a question, but we do have to move through all of these speakers. When we've done this live, it's been kind of a fun pop-up kind of experience, and I'm not exactly sure if it'll pop up, but at least we do have a summary slide for each of the posters today. So, as you can see, you know, I think it's a mission of ACES and should be more and more a mission to bring the full breadth of the people that are working in the field forward. Some of these folks are from other countries, some of them are student voices, some of them are researchers that are doing work in cities across the country that we seldom hear from. And some of them are old hands, people that have been working in solar industry for a long time and clearly never give up. So I just really want to give a salute to the folks that are on this panel. I do wish that I was there in person so that I could meet each of you personally and get to know more and more about the work that you're doing. So when you do introduce yourself to each of our speakers today, I hope you all repeat your name and give us the proper name of your poster, because some of these poster names have kind of evolved since they were first submitted. And a little bit about the poster, where you're from, and the work that you're doing. I'm going to be setting a clock, and if anybody's running, you know, too long, I'll have to give you a ping. We have 4 minutes total for each poster, but I'm hoping that you'll speak for about 3 minutes, maybe a little over 3 minutes, and then we'll have a quick question if there is any. So let's get going. This is page 1 of our speakers. This is page 2 of our speakers. And in our roll call, we really only had one presenter, possibly 2, let's say, who are not able to be with us today. So this is the first poster, and this came in as micromobility and renewable energy. Clearly, it's got a little different name. And if you don't minimize the speaker pictures, you won't be able to see the whole poster, because it's a pretty big one. So the speaker number 1, Tay?
Yes, that's correct.
Okay.
Okay. So do I screen?
The share screen should be up already, correct?
Yeah, you'll just speak right now about your research.
Speak, yeah.
Oh, so I'm not sharing my own screen.
There is a share already, and so people are looking at the slide that you sent us.
Oh, okay. So, all right, thank you, Jill. So like you said, it's gonna be a little bit small because I had a separate PowerPoint that I thought I was gonna just slide through and have bigger fonts, but it's okay. So good afternoon, ladies and gentlemen. My name is Taylai. I'm from the University of Arizona. So here in our lab, we mainly focus on the resiliency of a PV system. which includes battery, thermocouple, greenhouse materials, energy production prediction, and degradation mechanism of various PV technologies, both indoor and outdoor. And today, I would like to briefly go through a portion of our research that relates to electroluminescence analysis of PV module under accelerated life cycle testing. So just a quick recap that in an EO image, the dark area means that there's no current going through that region. This allows the EO to be used very often as an assistance to qualitatively identify the presence of physical flaws that are hard to see with naked eyes. And we're just wondering that, whether or not it can be a good indication of a quantitative efficiency degradation as well. We also want to approach this using an accelerated life cycle method without stress into extremely high or low temperature or relative humidity. So here in our lab, we have a full-scale industrial standard environmental chamber equipped with 4 arc lamps. And together they produce an average irradiance of 1,000 watts per meter square to mimic the daytime cycle. And between the 4 lamps, there's also an infrared camera that we use to capture EO images during the nighttime cycle. And we also play around with the settings just to make sure that we have the best resolution. We then try to correct the image by firstly subtracting the background from the EO to get the net EO image. And from that net EO image, if you look at the poster right now, which is in the picture in the middle, you can see that there's a barrel distortion as the edges are bent and the corners are pinned. So after removing that and adjusting the angles, the EO image is reoriented. When we enhance the contrast, then we run a Sobel filter, we expand the line width, fill the gaps in between them, and smooth out the edge. And that will create a clean image that contains just the panel itself. And also, individual cell is extracted. I'm not sure if you can see the 2 graphs. So one is on the left, and on the right, the other one, that's the statistical parameter that is shown in a intensity histogram, namely the mean and the standard deviation. Now, if you look at the central box of the poster, we can compare the 2. And then we found out that in our study, about 2/3 of the panel remain relatively healthy. And that means that 1/3 of them is displaying significant degradation. Now, in the top figure, you can see we have the 9 representative cells with the normalized intensity versus the exposure time. The variation here is less than 5%. You can see that the cell image has very minimal changes. Both mean and deviation remain relatively constant. But by contrast, if you look at the other one, the right figures show a clear decay in the EO intensity with losses ranging from 5% to 20%. The expansion of the dark spots in cell image is also more obvious, and the variation in mean and deviation is relatively large. Now, if we pair the EO intensity with the efficiency degradation, the figure that you see at the bottom right corner shows the PV efficiency in black and the EO intensity in red. The reduction in actual efficiency is about 0.35%, which is equivalent to a 2.3% decrease in relative efficiency as plotted in the figure. And as for overall, the we have a decrease of about 2.5%, and that's in close agreement with our efficiency degradation. So I think I'm running out of time, but just to mention that for our future work, we will apply a similar approach to smaller regions of pixels for finer analysis, such as line scan. And if you're interested in any of our other work, some of them are actually listed in our references, so please feel free to go and check them out. Thank you.
Thank you. That's great. Clearly, the commentary went more with the poster itself than the slide that you were able to see, but I think that gives a pretty good summary. And we are kind of out of time, but are there any pressing questions about that one? It says that there's one. However, I am not able to see it.
Steve Sargent asked, how achievable are widespread net zero carbon homes?
How achievable again?
Achievable.
I think they're quite achievable. It really depends on the cost. So whenever we have a good technology, it really depends on how you market it and how the governments are, play around with their policies to ensure that we're embracing the new technology. And right now, the cost to build a zero net home is a little bit not that low. It's getting lower, but it's not that low yet. But I believe in the future, when the costs go down, it's very, very achievable because we have the technology. It's just not widely employed yet. That's all.
Thanks. We better move to the next one. And to tell you the truth, I'm having a little trouble with operating the slide advance while still doing the Zoom. So hang on just a second. We're going to go to a little different format here. We'll do it this way because I think this is going to be easier to see. So is Bill Young here? Okay.
Yes, do you hear me?
Yes, there he is.
Hi, why don't you give us a summary of this poster? And I know that you have a new version of your poster going up soon, but just for a few minutes, give us the summary, Bill.
Am I on camera or no?
I don't see you on camera, but we are looking at your poster slide that says emergency power for all disasters.
Okay, there we are. I got all the buttons pushed. I did a full paper on this, regular professional paper. So if you want to get to the access system when I do publish the paper, you can get that. Of course, the poster you can see behind me, which other people have done their posters, so you can download the poster. So what I've done here is, for those who know me, I've been using solar and disasters for like 30 years. And what I've done here is kind of put them all this technology and information into one paper. So the idea is that everything that everybody's going to teach you here, zero energy buildings, PV modules, quality, standalone systems, grid tied. But one thing we're not really talking about here is structural analysis of the buildings, the construction of the buildings. There's a group of people that do that. So whatever disaster hits you anytime, most of the time it's going to take the power out. And so what you're going to do is you need to be prepared, because in a typical disaster, like usually what I've done is, like in 1989, Hurricane Hugo, we took a bunch of portable things back then, radios and flashlights and so forth, and carried them in. Thousands of people carried in a lot of equipment. And it was a big, massive effort in time and cost, and people were suffering. But FEMA promotes the idea of having mitigation, about building things and designing things and have programs and processes that mitigate the effects and damage of a disaster. And that's what I would like to promote, is that I don't know who has a disaster plan, but I have one on the back of my closet. And you should have one too. So if you look at FEMA and what they say what to do, and you look at my papers and presentations I've done over the years here through ACES, is that you need to start with a structurally sound building. Okay, there's FLASH and their IBHS. There are two organizations that help you design disaster resistant buildings that are constructionally sound. Okay, now that you got this sound, hardened, fortified building, you can also put a hurricane room in there if you want. That even makes it better. But the next thing everybody talks about is energy efficiency. Of course, passive design, energy efficiency is the first things you do. Okay, now you're approaching the zero energy building concept, which is wonderful. Okay, so we're looking at producing as much energy as we consume. Okay, and so we're looking at building it in such a way we have distributed generation. So I just don't rely on PV on my house. I have solar hot water. I have other energy efficient equipment in my building, in my home. So a lot of this I tinker with my house. My wife isn't all that happy about that, but that's okay. So my house is over 100 years old. So back in 1903, when my house was built, there was no air conditioning. and they just built a power plant in town. So before that, there was no electricity. Okay. See, so I'm living in a house that isn't modern, so to speak, but has been modernized since then. And I want you to take it to the next step. So this building has survived hurricanes structurally. It has been made into a solar powered house by me. I'm using distributed generation because I have a solar concentrator. I have a solar hot water system with a PV module that runs the pump. So what I've done is I've integrated all these things that everybody's teaching here at this conference, except the structural design of the building. That's not part of what we've been doing, but I want you to look at that. And if you do a holistic approach and put all these systems and concepts into one building, you've now made a resistant, sustainable, truly disaster resistant building.
Great.
And that's what
Bill, thank you. We'll have to move along now, but that was a really good summary. And I appreciate very much this summary, because the poster will get a lot of views in the exhibit hall. Let's move to the next one. I know that we have, let's see, we had something in the chat area before we go on and see if there's anything. I don't see anything.
Oh yeah, I just posted about visiting the exhibit hall to see all the posters, and then
excellent.
We can check them.
Yeah, that's where it's at. Meanwhile, let's go to our next speaker, Jesse.
Good afternoon, everyone. I am a graduate research assistant in the Sustainable Innovative Solutions Lab at the University of Rhode Island. And this poster reviews and assesses the occupational risks associated with both rooftop and ground mount photovoltaic PV installations in the US. It also proposes practical solutions to mitigate them. It is significant because occupational risks result in loss of income, productivity, pain, and death. And solar employment and the volume of PVs installed are growing rapidly. PV installers are exposed to falls from elevated working surfaces. Historically, most fatal falls in construction involve ladders, roofs, and scaffolding, and occur from 30 feet or less. It is important for installers to receive training, informing them on the potential fall hazards on site and providing them with the necessary fall protection and systems specified by the Occupational Safety and Health Administration. PV installers can also develop musculoskeletal disorders such as sprains, strains, and soft tissue injuries from manually handling heavy loads, including PV modules, at awkward postures. Additionally, they can contract hand-arm vibration syndrome from using vibrating power tools for prolonged periods of time. Site-specific lifting programs can educate installers on the unique lifting hazards on each site. Manual handling tools and equipment can be utilized to eliminate unnecessary lifting. And reduced vibration tools and anti-vibration gloves can mitigate the harmful effects of vibrating power tools. PV systems also involve a multitude of electrical components, such as transformers, combiners, and the PV modules themselves. These components can expose installers to electrical shocks, burns, and arc flash. Therefore, it's important to have good lockout, tagout procedures in place and to use the proper protective clothing to protect installers from electrical shocks and burns. Lastly, installers can contract heat-related illnesses such as cramps, exhaustion, and strokes from working in hot temperatures for prolonged periods of time. Consequently, installers should be provided with shade, rest stations, fluids, and monitored for symptoms of heat stress. So in conclusion, this research can aid occupational safety and health professionals develop safety protocols that reduce these occupational hazards and provide an overall safe environment for PV installers. Thank you.
Thank you. Jesse, I had a question that I find a little bit irresistible. Are you planning to have a career in academia or in occupational health and safety?
I'm interested in both. Right now I'm in a PhD program here in the University of Rhode Island. So it's really a period of exploration for me to learn more about what it means to be a faculty, a professor, but also to learn more about what it means to be an occupational health and safety professional. So I'm more in a period of exploration now, trying to learn and see where I fit in. So I don't know, but right now I'm interested in a bit of both.
Fascinating. Thank you. Okay, so were there any other questions before I pummel forward here? Okay, so Nan, this is your paper, Development of Spectral-Based Methods for Analyzing Sunlight Effects on Indoor Thermal Comfort.
Hello, everyone. This is Nan Wang, come from the Department of Architectural Engineering, Penn State University. I'm a first-year PhD student under the supervision of Dr. Julian Wang. Our research is about a spectral-based method for analyzing sunlight effects on indoor thermal comfort. I want to begin with the mean radiant temperature, which is an important parameter to predict human thermal comfort by PMV model. But this mean radiant temperature is about the long wave radiation from the heated air. So for the short wave sunlight radiation, we have to convert it into the long wave radiation to get a mean radiant temperature delta to add up to the mean radiant temperature. Solar software is used to calculate these parameters. And in the left of the poster, we can see a figure. This is the interface of SolarCal software. It's a little small. We need 8 parameters to enter to get the mean radiant temperature delta. And the 4 parameters in the boxes are about the solar information, window information, and human skin information. And the 2 parameters in red, they are constant values, and the table lookup currently to enter these parameters, but it's not accurate because these 2 parameters are spectral based, which means they have different values at different wavelengths. So if we use a spectral based formula for these 2 parameters, it would be more accurate to calculate a final result. So to verify this, the usefulness of the spectral-based methods, we calculate the mean radiant temperature based on the constant transmittance, and it's in the first column of the table, the middle table, the constant values of solar transmittance and the human skin absorptivity, and the solar-based values, which in the 5th column and the 7th column. We get different mean radiant temperature delta values. We can see from the table that there is a 0.1 magnitude differences of mean radiant temperature delta, which depends on the spectral variations and the intensity of the solar radiation. And by this mean radiant temperature delta, we get different PMV values. We could see from this table, there is the red figure. There is 0.01 magnitude differences of PMV values, which is small, but they have big influences. You can see that the gray zone in the figure is the comfort zone, and the red zone is the zone which people will feel warm. So at the time of 14 o'clock and 17 o'clock, although the PMV differences is very small, but they fall into different zones, which we will get different conclusions. So in conclusion, there are decimal magnitude differences between constant parameters and spectral-based parameters of the total solar transmittance, average skin absorptivity, and then we calculate different mean radiant temperature and then PM wave values. Although the differences are small, but even minor differences in PM wave values may cause significant differences of thermal comfort levels. That's all. Thank you.
Thank you. And that, yeah, that explains partly why we thought we would just show slides, because there's a lot of depth there that folks will have to go after in the conference hall. Are there any immediate questions about this one? Wonderful. Okay, so next, Thomas Dietz, building a zero energy home.
Okay, there you go.
Thank
Hello.
you. Very good.
My name is Tom Dietz, and I live in Afton, Virginia. You can see a picture of my home on the right-hand side in the slide. We live right at the end of the Shenandoah National Park and at the beginning of the Blue Ridge Parkway, a beautiful part of Virginia. And we retired here with a plan to build a zero energy home. I figured out that the best way to impact change is to start doing it yourself. And so we set about to do that. We designed the home ourselves without any assistance of professionals, and I'm not a solar professional in any way. We ended up building about a 3,700 square foot home. It has two different solar arrays, a 110 kilowatt array on our barn and a 5 kilowatt array on my wife's quilting studio. So the he shed and the she shed. We also have a geothermal heating and cooling system. Very importantly, we put the proper insulation, heavy insulation into the home. We've designed the home for passive solar design. So we have very large windows, south facing with the proper overhangs so that we get solar gain in the winter and not too much in the summer. We even made sure that we picked the proper windows so that we had energy efficient windows, of course, energy efficient lighting and appliances. We even have a wine cellar that was built into the north side of the basement that runs off of the geothermal loop. The overall project, it was important to us that it would be economically feasible. It does have a 10-year payback on all the energy investments, which were about $75,000 before the tax rebates. So about $62,000 after the federal tax incentive. And I calculate that we will get about a 6 to 8% return on investment per year for that investment over the 25-year period. So some of the key learnings for us is that the first and foremost thing you should do when thinking about designing an efficient home is insulation. Make sure you have proper insulation. Pick the right HVAC system. Get a high efficiency heat pump. Use passive solar design principles. And then we actually are energy positive. We actually produce more energy than we produce more energy than we consume. So we also have an electric vehicle, and we have as many electric appliances as we can, so we can consume some of that excess energy. I guess the bottom line is this can all be done by a homeowner with very little experience. All they have to do is go out there on the web, do some research, talk to people, and they can figure out how to make this happen.
Great. Thank you, Thomas. Just a quick question. Did you by any chance present an early stage version of this at a previous conference?
No, I did not.
This is a new one. Okay. Okay. That's great. Occasionally we do have people who have built their own homes participate, as poster presenters, and it's always very popular for some of our visitors who are thinking about doing it themselves and want to see, what someone else's experience was. There is one more question in the Q&A, but let's see. Okay, love that you have passive solar. Do you know the approximate square footage of your south windows?
I know that I can stand with my arms spread wide in the largest window. It's quite large. The views from this home are just outstanding. We have mountain views on almost every direction. So it was very important when we built the house that we maximize the aesthetic value of living in the beautiful place we do.
All right, thank you. We'll have to move to the next one. This is Thomas Bartholomew.
Yes, hi. My name is Thomas Bartholomew. I work for the DC Department of Energy and Environment in Washington, DC. You'll hear from some of my other colleagues to talk about other aspects of our Solar for All program. But I wanted to talk a little bit about our efforts to sign up subscribers for our program. So our program is focused on sharing the benefits of solar with low and moderate income residents. We're primarily focused on delivering those benefits through community solar, though we do have a single family solar component. So we're trying to reach eventually 100,000 families within the district and save them about 50% on their electric bill per year. So the program, the use of administrative data is kind of I think a useful way for any state or locality that wants to do a program like this. So, Richard Thaler has the principle, if you want somebody to do something, make it easy. And so using administrative data makes it much easier for customers to access your benefits because we are able to target folks that automatically qualify for our program using our knowledge of their benefits through existing government programs like the Low Income Heating and Energy Assistance Program, Food Stamp Program, SNAP, Social Security, and welfare benefits through TANF. So targeting residents who already have those benefits means we already have their information. We just need them to sign up with us. So it's a much simpler process. It's much less administratively burdensome for the resident. It's a much simpler process for them to fill out. And we just have to focus on the part of sort of allowing them to understand what the program is all about. It's about about the solar benefits, the savings that they can have, so they can be convinced to sign up. And then also just go through explain to them what the benefits would mean for them. So we've targeted subscribers through a mail subscription campaign. Through that, we've had a take-up rate of between 2 and 5%. We've also, prior to the coronavirus, we had been signing people up at benefit centers where they were already engaged in business with the government. So it was much, much faster for them to do that. They already had a lot of their documentation they might need, and they were already there, so they weren't spending additional time connecting with us. We're working on, now that coronavirus obviously limited our ability to do in-person outreach, to work with properties whose residents are automatically income qualified because it's an income covenant property. And we're exploring using working with other NGOs to do that as well. That's it.
Wonderful.
Really cool project. I have a question. Are there many community solar? Is there a lot of community solar in the DC area? Are there many projects going on there for that?
Yeah, I mean that's our main focus. So we I think we put out about 7 megawatts last year, and we're looking to put out another 7 this year.
That's great.
Okay. Now this one is Rahim forecasting carbon emissions in 7 eastern states of the US. Rahim, if you could take this one over.
Hello, everyone. Thank you, Jill. My name is Rahim Khoie, and I'm a professor at University of the Pacific. And Jill asked Jesse about what he wants to do after he graduates. Here's my suggestion. Go to academia. It is so rewarding. You know why? Because you get these graduate students, in my case, Antonio Calderon, and they do great work, and you get the credit for it. So join university, go to university. It's a very rewarding career. All right, my talk is about forecasting the carbon emissions, and not 50 years forecasting, just 5-6 years of carbon emission of the United States, especially the effect of the coal deregulations that the present administration has actually initiated. Let's look at this one. I have only 4 plots, so let's look at the top left. What this shows is the US total emissions, not just electric sector, but total emission over the last several years. And notice that in between 2007 and 2017, there was a significant drop, almost going from 6,000 million ton to 5,000 and change, 12%, significant. So unfortunately, however, in 2018, there was an uptick. The US emission went up by 2%. We selected 7 eastern states. These states are West Virginia, North Carolina, Ohio, Kentucky, Pennsylvania, in large part because of their heavy reliance on coal electricity. In fact, in 2012, they told Obama that, Mr. President, if you want to be reelected, you better kind of soften your position on coal. And he came up with this clean coal phenomenon. But anyway, what we have done is we have actually developed a model that is called ARIMA, which is autoregressive integrated moving average model. Antonio did all that hard work. And what we did was, we did quite a few scenarios. One of them was, what would have happened if the regulations that Obama imposed, and by the way, notice that in all those 7 states, there was a significant drop in CO2, just collective of those 7 states. What would happen if you actually, if you had continued the regulations? And our model predicted that in the next 6-7 years, by 2025, there would be a significant continued drop in coal. However, when we actually took the data from 2010 and prior to that, where we believe these deregulations did not happen, our model predicted that the CO2, US total emission is going to go up. In particular, the emissions of these 7 states will go up. We did this quickly. We did this analysis, this study in 2019 at the time where this data wasn't available. 2018 CO2 emissions were not reported. And guess what? We were correct. So this uptick that you see here is actually the uptick that our model actually predicted. In conclusion, let me end by saying that 100 million ton of CO2 is the amount of increase just in 2018. You and I and a lot of amazing people are doing everything they can to save, I don't know, 10 ton of CO2 or 1 million ton, and yet deregulation by federal government can wipe all that out. With that, I thank you for your attention.
Thank you. Any questions? All right. I was interested by the span of possibilities from the best case to the worst case in each one, and I suppose after a year of COVID, we'll see where we are along that scale. The next one, this one here is an assessment of carbon payback time of photovoltaic systems considering Brazilian solar irradiance variation. And this is Mauricio. Can we have you online?
Yeah, sure. I'm here.
All right, thank you.
And so, hello everyone. I'm a master's student in Energy and Environmental Laboratory at the University of Brasilia. And my research objective is to assess the carbon payback time of a on-grid rooftop mounted photovoltaic plant under the Brazilian solar radiation levels. And this is because like little is known about the environmental impact of PV technology. And also in Brazil and worldwide, PV technology is advertised as a zero carbon technology, but that's not true. So I would like to investigate what's the impact in the Brazilian electricity grid. This is because 85% of the electricity used in Brazil comes from renewable sources. And since 2012, the Brazilian solar PV market has grown more than 600,000%, reaching 2.85 gigawatts in installed capacity. So when you analyze like where the PV equipment is manufactured and then where they are installed, there is a big if in the carbon emissions. So I use the 4-step methodology, and the first step is to define a technological arrangement. In this case, I define a PV plant with a nominal power of 1 megawatt. Then I calculate all the equivalent carbon dioxide quantity during all the life cycle of the power plant, considering the manufacturing origin. In this case, it is China. And I estimated the electricity production during the lifetime, which is 25 years. And the last step is determine the carbon payback time by comparing the annual equivalent CO2 emissions to the PV plant, to the Brazilian grid, and then define how much the CO2 was avoided. So based on this methodology, I was able to create this heat map where you can see that the carbon payback time runs between 6.5 and 14.5 years. And also I was able to find out the manufacturing process of the PV panels, cables, and inverter and mounting system was responsible for 99.1% of all emissions. And moreover, the find supports that the PV technology insertion in Brazilian grid is beneficial to climate change mitigation. But like our studies has its limitations because the data usage was a little bit old, and meaning that the results would be pessimistic to some extent. And that's it. Thank you.
Thank you. Mauricio, could you give us again your full name? And I also had a question. I know that one of our ACES fellows has done a lot of work in Brazil. Have you ever worked with Larry Kazmierski?
No, I haven't worked with him. And by the way, like
Brazil, yeah.
Yeah.
And what was your full name again?
It's Mauricio Almeida-Pinto.
Okay, very good. So watch for this poster in the exhibit halls, and you can learn more about that vast country. Okay, so we're going to do this poster, and then we're going to take a little stretch break. Because we're only halfway through, but I want everyone to be paying full attention as we continue. This is Jacob Hibben. If you could bring yourself online.
It looks like he might be having issues connecting to audio, so we might want to move on.
Okay, yeah, because he was here during the roll call. If we have a minute at the end and we can get him online, we'll return to this one, estimation of hourly solar radiation using DM and GRNN models. And I assume that DM is data mining and GRNN is generalized regression neural network method. So we still don't have him online. So let's go to the next one, which is a little short video to introduce a video piece that we're going to play into the break after this session. And then after we watch that little short video, we can all kind of stand up and take a break. Is Jennifer with us?
Yes, thanks, Jill. Good afternoon, everyone. My name is Jennifer Johnston, and I'm an Energy Program Specialist at the District Department of Energy and Environment. As Thomas, my supervisor, mentioned, the district is ramping up our efforts to deploy solar for the benefit of low-income district residents through our Solar for All program. The program was established in 2016 through the Renewable Portfolio Standard Expansion Amendment Act. And the goal of this program specifically targets to provide benefits of solar electricity to 100,000 low to moderate income households and reduce their electricity bills by 50% by 2032. The department had the pleasure of working with Pendragon Productions to help document the successes and challenges of the first 2 years of implementing the Solar for All program through an 8-part web series. Each episode of the web series focuses on a different aspect of the Solar for All program, with the first episode exploring the legislation and the last episode discussing what's next for the program. We have a consolidated 20-minute version that combines the most impactful portions of the webisodes into one cohesive documentary. And as Jill and Carly mentioned, that's available through the exhibit hall, and we're the only video listed there. So during this time, I'd love to show the trailer to give you guys a little bit of a taste. And then if we have time at the end of the session, would also love to play you all the first webisode. So while I'm pulling that up, I do also want to mention, Jill.
Oh, I need to stop sharing, correct?
Yes, that would be great.
Okay.
Thank you kindly. And before I get this started, I also want to mention that we're very proud of this documentary. It was nominated for an Emmy, as well as selected for the DC 2020 Environmental Film Festival. So here we go.
We always have a little trouble with the audio, so you may have to turn it up.
What was that, Jill? Oh, okay.
I don't know if people are getting the audio.
Are people hearing the audio? No? Okay, I'll send the link to everybody, so then you can just view it on your own. Sorry.
I do recall that Carly C had a little issue with audio, and that she got a little tech support during the opening session when we were watching Dennis Hayes. So let's see if we can get that information to you, Jennifer, or to me in the next 20 minutes or so that if we are going to try again, it'll work. Okay?
That sounds great.
Okay, great. So I've turned everybody on just so we can like see that we are all here. Here we are. Hello. I would like to take just a minute for everybody to like stand up, and you can turn your video off and kind of shake your arms, and then we're going to sit down and we're going to do some more. So I've been stopwatching everybody's speech. So I'm going to stopwatch this for 30 seconds. Starting now.
Hey, Jennifer. So when we want to play videos, it's best to have it downloaded to your computer. Do you have like the actual video downloaded by chance, or do you just have it on YouTube? Oh, you're muted. I can't hear you.
Sorry, girl. Everything either on YouTube or Vimeo. We don't have anything. The producer has all the hard copies.
Okay, yeah, so that's why kind of you want to have it downloaded, because then you can actually play the computer audio when it's on YouTube and Vimeo. We don't have that option. That's where it gets a little hiccupy. But we can definitely, you can post the link and send it to the attendees and panelists so they can watch the preview there. And then everyone knows we've got the long version in the exhibit hall for people to watch there as well.
Great. Okay, I'll send you a nice email.
Great, sounds good.
And we can experiment one more time at the end. Okay. I don't remember if Tom Thompson was here today.
I do not see Tom.
Okay. Okay. So then we're going to go to Hyon Ra. Hyon?
Hyon.
Hyon. Oh, I'm sorry. I thought I wrote that down right.
Spelling is funny. I blame it.
Hyon. You actually have 2 posters, right?
I do.
Okay, so let's get those up. And I'm going to have to do a screen share.
Okay. So how should we do this?
You will just, for some reason, that's showing larger than life, and I don't know why. There. Okay, go ahead.
Okay, great. So good afternoon, everybody. I'm Hyon Ra, principal and founder of Ra Solutions. It's a consultancy focused on bridging the gap between investors, developers, technical experts, and community members by providing integrated water, energy, and built environment strategies. I'm also a faculty member at the University of the District of Columbia's Department of Architecture and for Goucher College's History Preservation Master's Program. So in 2018, utility scale solar accounted for almost 60% of all new solar energy capacity in the US. So as this shows, utility solar is clearly an important part of our clean energy future, but it can be a lot more, especially for the rural communities where most of these developments take place. Utility solar, by definition, as I'm sure you're aware, feeds the solar power generated into the utility grid for the host customer for a fixed amount of time, usually spanning decades. So this means that for these decades, fixed amount of time, the local community does not directly benefit from the power that's generated in their own communities. As a community member, the tangible benefits of this type of development are difficult to see unless you have a stake in the land that is being leased for the solar farm. So this, paired with the fact that many local communities only find out about these developments when public announcements about them are made, has led to project delays or outright opposition by community members, and consequently, more financial costs for developers. Creation of local construction jobs is something that's quoted a lot as a local benefit, but it's really not a significant benefit for these communities because the jobs are temporary and very few in number, to be honest. Engaging with the community early and incorporating measures to address these local issues into the project scope can really help earn community support, mitigate the risk of unnecessary project delays or cost, and position utility scale solar development as a rural development partner. Every community is different, and there are many strategies to leverage and rally community support by extending tangible benefits. So these include using policy and regulatory frameworks, existing workforce or economic development programs, and issues that local communities are concerned about, for example, public education. So in the poster that I hope you'll have a chance to check out later, I've listed 3 such examples. One is a project I was involved in which the utility scale solar project benefited public education. The project team actively sought to develop on a site owned by the Arizona State Land Department, knowing that a significant portion of the land lease that goes to this particular department would go directly towards the state's K-12 public education and teacher funding. So, and the other examples are of pollinator-friendly solar farms and co-location of agriculture and solar farms. They create additional revenue streams for community members through employment and products that they can sell. And ground cover and vegetation have proven to help panel performance by stabilizing the soil and reducing air temperature. So I look forward to speaking with you during the Q&A and perhaps at the networking lounge. I'm not sure how that works yet. And thank you for listening.
Okay, thank you. Any immediate questions on that? All right, I'm interested to hear this one. Historic preservation as a means to scale up solar energy development.
Okay, so I'm gonna do a quick introduction again so that it'll be a two separate clip. Sorry, give me a second here. Oh no, sorry. Okay, now, good afternoon again. Hyon here, principal and founder of Raw Solutions. Again, it's a consultancy focused on bridging the gap between investors, developers, technical experts, and community members by providing integrated water, energy, and built environment strategies. Also faculty member at the University of District Columbia, and also at Goucher College's Historic Preservation Master's Program. So this poster, I'd like to start by addressing a preconception, which is that historic preservation and solar energy do not go together. In reality, they're complementary, especially in a building scale, and there are many benefits to combining the two. The National Register of Historic Places grants special status and prestige to historic buildings, monuments, districts, and sites in the US. So it's not just for buildings. However, only federal properties listed on the register are legally protected from damage or demolition. And currently, there's only 7% of federal properties listed in this register. So that means about 93% of listed properties are at risk. So I'd like to focus on the building scale today for the topic, as the topic of our discussion. Historic buildings often evoke images of pristine Victorian houses or grand neoclassical buildings, but buildings where historic events occurred that are significant are also listed regardless of their architectural significance. For example, a church where prominent civil rights activists used to meet could be eligible to be listed in this register and have been as well. The combination of these two factors that I just mentioned mean that historically significant buildings, especially in minority communities, are often lost to make way for new developments from usually complete demolition. Another challenge is that increasingly stringent energy performance regulations are already in place in major cities, such as Washington, DC and New York City. This includes renewable energy standards, and historic buildings are not exempt, and it's retroactive as well. So this is where solar energy comes in. Installing solar systems in historic properties will help meet new energy performance standards. This could also give investors more financial benefits, especially in places with an active solar renewable energy credits market, so SREC market. That's about 5 states at the moment and the District of Columbia. And the SRECs can be stacked with historic preservation and federal solar tax credits. Retrofitting historic buildings and installing solar can also be faster than new construction. And historic buildings, as a bonus, offer character and meaning that new construction simply cannot. Studies have linked historic districts to above average property value increase compared to others, and also improved walkability. So in addition to the financial and logistical benefits, combining historic preservation and solar energy can support local economies and livable communities. So there are examples of such approaches and more details on stacking the various benefits on my poster, which I hope you'll take time to check out. And I look forward to talking with you further on this. Thank you.
Right. Well, thank you very much. I appreciate that. In my own work, I have been doing some advising on upgrading buildings and windows, which
yeah, that's a big thing, isn't it?
I learned a lot from the historic preservation community even for homes that don't necessarily seem to be extremely historic. You know, they're just homes, but there's so much research and intelligence that has gone into studying these homes that we can all stand to learn from that. Any other questions on this or the previous one on rural communities? Okay, so now Fahia, effective zinc doping, if you could introduce your paper.
Okay, hello and good afternoon to you all, though it is midnight here in Malaysia. So I am Fahia Munna. I am a graduate research assistant in Solar Energy Research Institute in National University of Malaysia. So basically I am working on thin film solar cell. Thin film solar cell, actually there are various layers. However, I am working on the buffer layer to actually enhance the layer property to achieve higher efficiency. So today I'll be presenting the summary of my poster, which is the effect of zinc doping on the optoelectronic properties of cadmium sulfide thin films deposited by chemical bath deposition utilizing an alternative sulfur precursor. So my buffer layer is cadmium sulfide, and I am doing zinc doping to increase its optoelectronic properties, and the method I have used, that is chemical bath deposition. So after the experiment, the results that I have found, that is optical transmittance has increased with the increase of zinc concentration, and also the band gap that we have found, that is 2.45 electron volt for using N-methylthiourea rather than using the usual one, which is thiourea. And also the average transmittance is around 500 to 800 nanometers. And from the XRD characterizations, we can see that the peaks are more sharp and intense for using N-methylthiourea. And also when the zinc concentration is increasing, the peaks are also very intense. And for the electrical properties, we can see that using N-methylthiourea, the range is around 10 to the power 14 centimeter per cube to 10 to the power 15 centimeter per cube. So if you have any other questions, you can go through to the PDF, which has already been uploaded in the conference, and you can ask questions. Thank you for your time and attention. Thank you so much.
Excuse me, could you remind us what institution you've been working with?
I am working in National University of Malaysia.
Okay.
Solar Energy Research Institute.
Very good. Any further questions? Okay. So this one, we had a substitute speaker, Kimberly Bacalars.
Right. Yeah, sorry I don't have video working, but yeah, we had widened our poster scope to cover the full project. So Scott was supposed to present, but I'm going to present quickly for the full scope. So Tetra Tech, I'm with Tetra Tech. We're a consulting firm, global consulting firm, and we had teamed with Green Power Technology. That's the company Scott's working for. We were hired to perform quality control on the Solar for All grants that have been awarded by DOEE to ensure that the requirements that were outlined in their grant agreements were being met. So the scope covered 11 grant agreements, and our team conducted site visits to verify the solar PV installations, to gather meter data, to model production. And we, as you can see, we reviewed lots of documentation from each grant to ensure that the processes were well documented. So in terms of some of our findings that were showing up here on the slide, the documentation that was received was completed in a satisfactory manner and was compliant with each of the DOEE grant agreements. We did find that quarterly reports provided quite a bit of valuable information in terms of verifying the grant agreement requirements. We did note that as-built information could be updated to reflect actual installation more often. So sometimes the design plans didn't quite meet what was actually installed. And as expected, a lot of adjustments were made during the installation process. And then consistent document naming, retention policies, and templates could help grant managers with future reviews for upcoming grants. In terms of the production modeling, the modeling suggests that the production targets will meet the DC income qualified customers will receive the intended benefits from the projects. And what we did was we compared the design production from the documentation with some modeled production and then also the actual metered production. And we were finding that while the design estimates were conservative, the actual production was probably about 81 to 100% of the modeled production. And this was primarily due to things like shading, a few inverter issues or broken modules, and then some variability in the early operation of the systems. And then the portion of the project that Scott's company, Green Power Technology, worked on heavily was the installation verification on-site visits. So the on-site installation verification found pretty minor areas for improvement with only one issue needing immediate attention. And this just indicates to us that there were quality installations for all of the projects and that the third-party inspections were catching things pretty early in the process. Most common issues were things like missing labels, faded labels, no rapid shutdown. While these were not necessarily code issues, we did mention them as best practices. Some fairly significant but rare observations were a few missing racking clamps, missing ballasts, or cracked modules, as we mentioned before. And then a few minor but rare observations were things like grounding screws not outdoor rated, connectivity or monitoring issues, and shading. The one safety issue that was identified, which was resolved immediately, was a section of array not connected to the system's grounding circuit. And that's basically a brief overview of the poster. Both Scott and I will be available for questions, and feel free to reach out to Scott with any specific questions about the installation verification.
Thank you. So Kimberly, do you, as a conclusion, would you say that the number of verifications that you're doing on site is an adequate number or an appropriate number? Did you make any adjustments after doing this first round of inspections?
We did not have to make any adjustments. That was something that we were considering within the scope, and that we had, we're in communication with DOEE about. If we would have found any deficiencies, we would have increased the number of installation verifications, but we weren't finding anything that required us to add any additional on-site verification.
Okay.
Everything was looking good. Yep.
Thank you. The next poster is another one from the DC area. And for this, I have a Jack Akinlosotu. Please repeat your name so we get that right.
And Jill, I do want to note we do have a question in the Q&A for Fahia to answer.
Okay. Yeah, because let's do that real quick because I don't want to lose Fahia. I know it's late there.
Yeah, the question for Fahia is compared to conventional B/P doped panels, do you have a higher band gap and more charge carries? Is it overall more efficient?
Oh yeah, if you use the normal Thioria, then the band gap you will get is 2.4. But now I am using N-methyl Thioria, so I have got 2.45, but I am working on it more so that I can improve its carrier concentration. So I am also giving effort to get more carrier concentration and mobility. So hopefully by using N-methyl Tharia, we can achieve that, hopefully.
Okay, thank you. Okay, and this is Paarth Gupta, solar EV chargers and superflow batteries. We haven't had any other EV presentations, so I look forward to this one. Paarth, if you can get on and take the mic.
So hello everyone, my name is Paarth Gupta and I am a mechanical engineering student at Srimata Vaishno Devi University, India. The title of my paper is Solar EV Charger and Superflow Batteries for an Efficient Electric Vehicle. So I'm going to discuss about solar power and electric vehicles, or we can say a combination of solar power and electric vehicles. As we all know that enough sunlight strikes on the Earth's surface to fulfill the world's energy need in 1 hour. And the average lifespan of a solar panel is more than 20 years. The US has approximately 2.5 lakh electric vehicles and 5 lakh solar rooftop, and both industries are growing exponentially. So my question is, are electric vehicles an eco-friendly mode and fast mode of transportation? There's a quote, electric vehicles are not a solution to the problem. It is just transferring the problem from fuel to chimneys. The solution to the problem lies in solar power. So now I will discuss the two main problems related to electric vehicle. And yeah, I will provide some solution to that problem. So the first one is, are electric vehicles purely a green mode of transportation? Yeah, they are, until and unless we are using a green mode of power for charging purposes. As you can see in the poster, the conventional DC chargers that we are using today are getting power through the grid, which is generating power using the fossil fuels that are indirectly polluting the environment. So for that, solar EV chargers are the best option. We can increase the efficiency by using the pulse width modulation to align the panels for maximum power generation throughout the day. And the panels can be attached to a motor controlled solar tracker, so receive the maximum sunlight at any given time in a day. So this was about the solar EV charger. So the second problem is, are EV electric vehicles the fast mode of transportation? I don't think so. With the increasing popularity of EV, the range anxiety is not being replaced by charging anxiety. Let us take an example. It takes a 15 minutes to charge the car up to 80% using the DC fast chargers. And it just takes 8 minutes to fill the petrol tank. So 15 is quite comparable. But imagine if you could charge your vehicle in just 3 to 5 minutes and it could give you 100 of miles. Yes, superflow batteries are the solution. They can charge in just 3 to 5 minutes and in 30 seconds by replacing the discharge electrode with the charge electrode. They have a long cycle life and low maintenance. As flow batteries can be charged and discharged more than 10,000 times, like lithium-ion batteries do not do. And they do not need to be replaced every 5 to 10 years like we have to replace lithium-ion batteries. So as per the result, this PV electric vehicle synergy and the use of superflow batteries reduces pollution and cures range anxiety. With a combination of solar EV charger and superflow batteries, both solar energy utilization and customer satisfaction will increase, and it will lead to sustainable energy development. With this, I conclude my presentation. For more details, you can see my poster in the exhibit hall. Any questions?
Yes, any questions? There is a question. I have a hard time opening. There it is. What is a superflow battery?
Superflow battery is the new generation of lithium-ion batteries, which is based on hydrogen battery, which can replace the electrode with the charge electrode to get the battery charged in just 30 seconds. And it can handle current up to 1200 of ampere, means we can charge it with the DC fast chargers.
And of course, the underlying question to that is, what is the general picture for the economics on superflow batteries? How does it compare economically?
Superflow batteries are very cheap in the cost. Also, they can provide enough charge for the electric vehicle to run about hundreds of miles. and they have IP68 rating, so that no degradation to the life of the battery.
And since we do have half a second left for a question, I was going to ask one more question. Are there any commercial EV vehicle manufacturers who are involved or looking at the superflow battery option?
No, superflow battery is just about to come in the market, and it will replace the lithium-ion batteries.
So that's you'll have to come back in a year or two and let us know how it moves into the market.
Yeah, absolutely.
And we did have someone send in a question for Jack, asking how exactly he built trust in the community for the Solar for All program. Jack, if you want to answer that.
Yeah, there are a number of different things that we kind of worked on as a team. One of the big things is that now we have an outreach team that specifically their job is to go out and speak to people directly and explain the benefits of our program and really let them know in person, and build that person as a person who works directly for the government, and kind of work that way. Another thing that I think really helped us in kind of getting the ball rolling was to send out pre-approval letters to some people who we knew were eligible to the program. And we did that through what Thomas was talking about, looking at other programs that people are already using, and they go to our agency for and saying, hey, if you're approved for this program, such as LIHEAP, you'll be approved for Solar for All as well. So people had that trust of LIHEAP already, and knowing that we're a part of the same agency that distributes LIHEAP, I think that kind of helped us a bit in terms of actually getting that credibility over time.
Excellent. Thank you. We actually had one more speaker, if she is available. Is Shelley Cohen here? Shelley.
I'm here.
Yes, hi. So you are with the Sustainable Energy Utility in DC. I don't have a slide for you, but why don't you talk for just a minute about the poster that you were preparing?
Sure. Well, we've already heard a lot about the Solar for All program. But I'm going to add to that a little bit. My name is Shelley Cohen, and I am Director of Solar Programs at the DC Sustainable Energy Utility. And a lot of what you've heard today has talked about the first few years of the Solar for All program, which is this innovative program run by the District Department of the Environment. And what DOEE has done is they've expanded different aspects of the Solar for All program. And so one aspect of the Solar for All program is now run by the DC Sustainable Energy Utility. And through that, we are currently rapidly deploying solar across the district. So we've sort of, we're building on their good practices and where they started out over the first couple of years. And we're building upon that and deploying even more solar. So last year we were able to bring 7 megawatts of solar online through our, which was community solar. And all of the community solar goes to benefit low-income residents in the district. So with the community solar, the thing that is so innovative is all of the output goes to DOEE, and DOEE then signs up subscribers for that, for all of the solar produced. We also have a target of putting solar on 100 homes each year, and over a 3-year period. And so that will also contribute to deploying more solar for low-income residents across DC. On my poster, I have a couple of examples of where we've done some solar in the community. One is we were able to deploy a solar project at the Children's National Medical Center. That was over 1 megawatt of solar that was put onto the garage at the center. And this innovative project, they actually built a structure above the garage to host the solar. And, you know, of course, here in DC, we have